Usually when we talk about cybersecurity, there's this expectation of, well, walls. You build a firewall, you lock the vault, you check the IDs at the door.
Right, yeah. A hacker is either inside or outside.
Exactly. It's binary.
The threat is external, the software is deterministic, and the data is mostly static. It's comforting because it's predictable.
But then you deploy an AI agent inside your network,
Yeah.
and suddenly it's like you've invited a brilliant but, wildly unpredictable guest right into the vault.
Absolutely.
It's learning, it's making decisions, it's chaining tool calls together. That firewall doesn't know what to do with it.
It is the absolute definition of an invisible attack surface. The rules of traditional IT security they just don't apply in the same way anymore.
And that is exactly why we are here today. Welcome to the deep dive. If you are prepping for the CompTIA SecAI Plus exam, consider this your conceptual masterclass.
Oh, we've got a lot to cover.
Yeah, today is laser focused on section 28, which is AI compliance and exam prep.
We have a massive stack of study materials to synthesize for you. We're pulling from the NIST AI Risk Management Playbook, ISO standard definitions, the actual legal texts of the EU AI Act, corporate AI policies, and the official CompTIA study decks.
Our mission today is simple. We are cutting through the heavy regulatory jargons, all that framework alphabet soup.
There is a lot of it.
So much. We're going to distill exactly what you need to know to understand the mechanisms of real-world AI governance so you can conquer those scenario-based challenges on the test.
Right.
Okay, let's unpack this. Why exactly is traditional cybersecurity no longer enough for AI?
Well, it comes down to the fundamental nature of the technology. Traditional frameworks like ISO 27001, they look for static signatures.
Okay.
But AI systems are dynamic and probabilistic. They introduce risks that a legacy firewall simply cannot detect. For instance, if you give an AI agent access to your corporate network, traditional role-based access control, or RBAC, often just falls apart.
Wait, I'm struggling to see why. If I give an AI agent access to my CRM system, isn't that just standard role-based access control? I mean, I give it a role, it has limits.
In theory, yes. But here is the mechanism you need to know for the exam, and it's called action amplification.
Action amplification.
Right. An AI agent doesn't just execute one hard-coded task. It uses probabilistic logic to figure out how to fulfill your request.
Oh, okay.
So a user might give a totally benign instruction like, summarize my recent client emails. But if that AI has broad traditional RBAC privileges, it might translate that single instruction into 50 different API interactions.
Oh, wow.
Yeah, inadvertently querying the entire client database and outputting data the user shouldn't see.
So it amplifies a simple action into a massive data exposure because it's creatively trying to solve the problem.
Exactly.
That completely breaks the traditional access model. You need dynamic, tightly scoped API permissions, not just a broad user role.
Precisely. And that leads to another major corporate policy headache you'll see on the exam, which is shadow AI.
Now wait, we all know shadow IT. That's when an employee secretly buys a cloud server on their corporate card without telling the IT department.
Right. Classic.
Is shadow AI just the same thing, but with AI?
It's much more insidious. Shadow AI involves employees using unsanctioned external AI tools like pasting proprietary source code into a public large language model to find a bug.
Oh, yikes.
Yeah, they aren't buying hardware. They are freely exposing highly sensitive corporate data to an external algorithm that might use that exact code to train its next model.
Which means your company's secret sauce is now part of the public AI's brain. So how do corporate policies actually catch and stop that? Dashboards look for fixed errors. Are they literally having humans read every AI input and output?
What's fascinating here is how organizations are layering their defenses. They use strict input and output policies.
Okay, how does that work?
For example, before a prompt ever leaves your internal network to hit an external LLM, an input policy runs an automated redaction script. It strips out social security numbers or proprietary keywords.
That makes sense.
And for irreversible, high-risk decisions, like a medical diagnosis, they mandate human-in-the-loop policies.
Human in the loop.
Right, HITL. A human must review the AI's reasoning, not just its output, before the action is taken.
And to keep track of all these moving parts, the sources mention the AI Bill of Materials, or AI BOM. It's essentially an ingredient list.
That's a great way to put it.
It tracks every algorithm, every data set, and every third-party API integration. So if your AI suddenly starts hallucinating or acting maliciously, you can trace the supply chain to find out exactly where the poisoned data or flawed logic was introduced.
That supply chain visibility is crucial. But, corporate policies are great in theory. When an auditor or a regulator knocks on your door saying, we try our best, isn't a legal defense.
Definitely not.
You need a verifiable blueprint, and that's where global standards like NIST and ISO step in.
Which takes us to the heavyweight frameworks. For the SecAI Plus exam, you have to know the NIST AI Risk Management Framework, or AI-RMF.
Yes, very important.
It's a voluntary, rights-preserving guideline built around 4 core functions: govern, map, measure, and manage.
And the order of those functions is vital. Govern is your North Star. It's the foundational culture, the ethics board, the overarching policies.
Okay.
But the technical sequence is map, then measure, then manage.
I always try to visualize the mechanism here. Why must we map before we measure?
Because you cannot measure a risk you haven't contextualized.
Yeah.
In the map phase, you establish the context and identify dependencies. Where is this model going to be deployed?
Right.
Who are the users? What are the specific threat vectors? Only after you map that terrain can you move to measure, where you use quantitative metrics to rigorously test for trustworthiness.
Let me try an analogy. Think of one of the major AI risks, model drift, where an AI's accuracy degrades over time as real-world data shifts away from its training data.
Sure.
Model drift is like a ship's compass that slowly loses its true north because of local magnetic interference.
I like where this is going.
In the NIST framework, MAP is identifying that you are sailing to a highly magnetic area. Measure is checking the compass daily to quantify exactly how many degrees off true north you are.
Spot on.
And manage is actively recalibrating the compass, or in AI terms, retraining the model to fix the deviation.
That's a highly effective way to conceptualize it. But for your exam prep, here is the critical distinction. NIST focuses on what risks to care about and how to structure your thinking.
Okay, so it's structural.
Right. If you need certifiable proof to hang on your wall for an auditor, you look to ISO, specifically ISO IC 42001.
Right. ISO 42001 is the certifiable AI management system standard using a continuous plan do check act methodology.
Exactly.
And the study guides also highlight ISO 27090, which provides specific guidance on AI-centric security threats, like data poisoning or evasion attacks.
So NIST and ISO build your structural defense, but what's the actual penalty if that defense fails? That takes us from voluntary guidelines to mandatory international law.
The big leagues.
Yeah. The biggest player here is the EU AI Act.
The EU AI Act is groundbreaking because it uses a very strict, risk-based tier system. At the top, you have unacceptable risk.
And those are banned entirely.
Think government social scoring or real-time remote biometric identification in public spaces. Banned. Period.
That the next tier down is high risk. These are AI systems used in critical infrastructure, medical devices, or tools for employment screening.
Serious stuff.
Very. These require rigorous third-party conformity assessments and continuous human oversight. And if you fail to comply, fines can reach up to 7% of a company's global sales turnover.
Here's where it gets really interesting. Context is everything. The exact same underlying LLM technology could be classified differently based purely on its application.
Right, absolutely.
If that LLM is powering a retail chatbot telling you what aisle the shoes are in, it's classified as limited risk. The main obligation is just transparency. The user must be notified they're talking to a bot.
Right.
But if you take that exact same LLM and use it to screen resumes for a job at that shoe company, suddenly it is high risk and subject to massive regulatory audits.
If we connect this to the bigger picture, this is exactly why data sovereignty and geographic deployment matter so much. Where the AI operates determines which massive fines apply.
Which brings us to Europe again.
Right. Under the GDPR in Europe, you have strict principles, like purpose limitation.
Let's ground that in a real-world example.
Right.
Purpose limitation means if you collect a user's phone number strictly for two-factor account security, you cannot suddenly feed that phone number into a secondary AI model designed to target them with SMS marketing.
Right. No cross-pollination.
The purpose is strictly limited to what they consented to.
Exactly. And another GDPR principle is data minimization, only collecting the absolute minimum data required. This becomes technically vital when a European user withdraws their consent.
Oh.
Yeah.
Right.
Under GDPR, you can't just delete their row in a database. If their personal data influence the AI's learned behavior, you have a major problem.
Wait, if the data is baked into the model's neural network weights, How do you remove it? Do you have to retrain an entire multi-million-dollar model just to make it forget one user?
It sounds crazy, right?
That sounds technically impossible and financially ruinous for a startup.
That is the core issue, and it's why machine unlearning is currently one of the hardest problems in AI engineering. It is financially ruinous, which is why regulators emphasize data minimization before training.
Just don't collect it.
Exactly. Don't put the personal data in the training set to begin with.
That is a massive operational shift. And to keep international companies from tearing their hair out over different regional rules, the sources heavily highlight the OECD standards.
Very important for the global picture.
They focus on ethical, transparent, and fair AI principles globally. In fact, NIST provides a crosswalk document demonstrating how their framework maps directly to the OECD recommendations, creating a harmonized baseline.
It's an interconnected web of governance, but let's bring this directly back to the exam. How do you actually prove this compliance?
Good question.
High-risk systems under the EU AI Act cannot just be self-certified. You need independent auditors to perform third-party evaluations.
And those auditors are going to ask for receipts. They want your AI bill of materials. And they're going to look closely at content provenance.
They absolutely will.
The study materials mention the C2PA standard. Can you explain the mechanism behind that? How does it actually prove where AI content originated?
Well, C2PA utilizes cryptographic watermarking attached directly to the data pipeline. When a piece of media or output is generated, C2PA embeds a cryptographic hash linked to a digital certificate into the file's metadata.
Okay, so it's baked in.
Right. If anyone alters the image or text later, the hash breaks, proving it was tampered with. It creates an immutable chain of custody.
So it's not just a watermark you can crop out. It's cryptographically bound to the file signature. That makes sense.
It's very robust.
Okay, let's test this knowledge. I want to play a quick game of Stump the Host.
Oh, I'm ready.
Hit me with a performance-based question, a PBQ, similar to what a test taker might face on the exam.
This raises an important question about practical application. Here is your scenario. You are a compliance engineer. An attacker repeatedly queries your newly deployed predictive health AI.
Yeah.
By analyzing the subtle changes in the model's confidence scores over thousands of queries, the attacker manages to mathematically reconstruct the sensitive medical records used in the original training data.
Oh, no.
What specific threat vector is this, and what control mitigates it?
Okay, let's reason through this. They aren't tricking the AI into ignoring its instructions, so it's not a prompt injection.
Right.
They are working backward from the output to reveal the training data. That is called model inversion.
Correct.
To mitigate it, I wouldn't use pattern recognition on the training data. I would need an output policy. Specifically, I'd implement a filter that rounds off or masks the exact confidence scores returned to the user so the attacker doesn't get the precise mathematical feedback they need to reconstruct the data.
Spot on. You've correctly identified the mechanism and the defense in-depth control. The key takeaway for the listener here is that evaluating an AI is no longer just about testing for high accuracy on clean data. A model can be 99% accurate in the lab, but completely fail when an attacker introduces subtle adversarial noise.
Right. The real world is messy.
The evaluation phase must include adversarial red teaming, bias audits, and continuous monitoring.
So if you take away nothing else from this deep dive, remember this. AI compliance is a fundamental shift. You're moving from guarding static data with traditional firewalls to governing dynamic, probabilistic models using continuous frameworks like NIST, certifiable standards like ISO 42001, and navigating strict laws like the EU AI Act.
I'll leave you with a final thought to mull over. We talked about AI agents getting smarter and action amplification.
Yeah.
As autonomous agents start chaining tool calls together without any human input, say, an agent researching, writing, and executing code across global servers autonomously, if that agent inadvertently violates the EU AI Act, who pays that 7% global revenue fine?
That is a great question.
Is it the developer of the underlying model, the corporate deployer who set the agent loose, or the end user who wrote the original prompt? Accountability in the age of autonomy is the next great frontier.
That is a terrifying and fascinating legal puzzle. Now, to perfectly round out your study session and lock in everything we just discussed, we are going to run a massive lightning round.
Oh, a pop quiz.
Exactly. This is the comprehensive practice test designed explicitly for the CompTIA SecAI plus Section 28 objectives. I'll read the questions, and you provide the answers. Let's blizz through all 9 domains. Ready?
I am ready. Let's do it.
Domain 1, AI compliance. Question 1, multiple choice. Which of the following best describes why legacy cybersecurity frameworks like ISO 27001 are insufficient for comprehensive AI compliance? A, they don't require password rotations. B, they focus on static data and deterministic software rather than dynamic probabilistic behaviors. C, they don't allow for cloud deployment. Or D, they mandate human-in-the-loop for all software.
That's B. Legacy frameworks focus on static data, not dynamic models.
Correct. Question 2. An AI system translates a single benign user instruction into a long sequence of API interactions, resulting in unauthorized data access. What AI-specific risk does this represent? A, data sovereignty. B, prompt injection. C, action amplification. Or D, model inversion.
Definitely C, action amplification.
Right. Question 3. Why is traditional role-based access control often insufficient for AI agents? Is it A, agents can't use API keys? B, agents operate with dynamic logic and broad privileges lead to access creep? C, RBAC is banned under the EU AI Act? Or D, agents only operate on local hardware?
The answer is B, broad privileges cause access creep with probabilistic logic.
Nice. Okay, PBQ time. Scenario: your company is deploying an AI system to automate customer IT tickets. Match the compliance control to the threat. The threats: 1. Shadow AI. 2. Data poisoning. 3. Privilege escalation. The controls are A. Pattern recognition on training data. B. Strict API token permission scoping. C. Centralized AI bill of materials.
Okay, for 1, shadow AI, you want C, the centralized AI BOM. For 2, data poisoning, you use A, pattern recognition on training data. And for 3, privilege escalation, you map that to B, strict API token scoping.
Perfect. Domain 2, the EU AI Act. Question 1. Under the Act, a government deploying an AI for widespread social scoring falls into which category? A. High risk. B. Unacceptable risk. C. Limited risk. Or D. Minimal risk.
That is B, unacceptable risk, banned entirely.
Question 2. A company develops an AI to review resumes. What's the primary regulatory burden? A. Banned entirely. B. Basic transparency. C. Rigorous third-party conformity assessments and strict data governance. Or D. No oversight needed.
Resume standing is C. It requires strict third-party assessments because it's high risk.
Question 3. What is the maximum fine for severe noncompliance under the EU AI Act? A. $1 million. B. 1.5 to 7% of global sales turnover. C. 10% of European sales. Or D. Revocation of cloud licenses.
The big one. B, up to 7% of global sales.
Okay, PBQ for Domain 2. Drag and drop these systems into unacceptable, high, or limited tiers. System 1, a retail customer service chatbot.
Limited risk.
System 2, a medical diagnostic AI.
High risk.
System 3, real-time remote biometric identification for public surveillance.
Unacceptable risk.
Crushing it. Domain 3, OECD standards. Question 1. How does the NIST AI RMF interact with OECD standards? A. NIST replaces OECD. B. NIST provides a crosswalk demonstrating alignment. C. OECD bans NIST. D. OECD is hardware only.
It's B, NIST provides a crosswalk to align with OECD.
Question 2. What's a core focus of the OECD principles? B. Fostering ethical, transparent, and globally fair AI. C. Centralized global servers. Or D. Setting parameter limits.
That would be B, fostering ethical and fair AI.
Question 3. Why are OECD standards vital for international enterprises? A. They provide a harmonizing baseline. B. They issue EU fines. C. They provide encryption keys. D. They replace local laws.
Definitely A, they create a global harmonized baseline.
PBQ for Domain 3. Match the OECD principle to the action. Principles are 1. Transparency. 2. Robustness and security. 3. Accountability. Actions are A. Maintaining an AI decision log. B. Disclosing to users they are speaking to an AI. C. Adversarial testing against prompt injection.
All right, 1, transparency goes with B, disclosing AI use. 2, robustness goes with C, adversarial testing. And 3, accountability maps to A, maintaining the decision log.
Moving to Domain 4, ISO AI standards. Question 1. Which ISO standard is the certifiable AI management system standard? A. 27001, B. 42001, C. 23894, or D. 5338.
Certifiable AINS is B, ISO 42001.
Question 2. Which standard offers specific guidance on AI risk management? A. 23894, B. 27090, C. 9001, D. 2701.
AI security threats fall under B, ISO 27009.
DBQ for Domain 4. Match the standard to the function. Standards are 1. ISO 42001, 2. ISO 5338, 3. ISO 2701. Functions are A. Legacy info security. B. Certifiable AI governance. C. AI software lifecycle processes.
Okay, 1, 42001 is B, certifiable AI governance. 2, 5338 is C, AI software lifecycle. And 3, 27001 is A, legacy info security.
Halfway there. Domain 5. NIST AI risk management framework. Question 1. Which core function focuses on establishing culture, policies, and accountability? A. Map. B. Measure. C. Govern. D. Manage.
The foundational one is C, govern.
Question 2. During which function do you track metrics and rigorously test performance? A. Map. B. Measure. C. Manage. D. Govern.
Testing metrics happens in B. Measure.
Question 3. An engineering team is tracking dependencies and intended use before deployment. Which function is this? A. Govern. Categorize these activities into govern, map, measure, or manage. Activity 1, establishing an ethics board.
Govern.
Activity 2, documenting specific data sources. Activity 3, adversarial red teaming to quantify drift.
Measure.
Activity 4, deploying anomaly detection tools in production.
Exactly.
Yeah.
Domain 6. Corporate AI policies. Question 1. What's the purpose of an AI bill of materials? A. Track dependencies and baseline models for transparency. B. Calculate ROI. C. Bypass privacy laws. D. Patch legacy firewall.
It's A, tracking dependencies for transparency.
Question 2. A policy mandates redacting SSNs before hitting an external LLM. What kind of policy is this? A. Output. B. Input. C. Shadow AI. D. Evasion.
That happens before generation, so it's B, input policy.
Question 3. Why mandate human-in-the-loop for high-risk decisions? A. Humans are faster. B. To provide explainable oversight before irreversible actions. C. AI can't generate logs. D. Legacy encryption.
Definitely B, to provide oversight before taking irreversible action.
PBQ for Domain 6. Match the governance component to its objective. Components are 1. Use case owner. 2. AI governance team. 3. Human AI collaboration framework. Objectives are A. Defines agent autonomy and manual overrides. B. Develops enterprise ethical policies. C. Determines operational boundaries and business purpose.
Right. 1. Use case owner maps to C, determining business purpose. 2. Governance team is B, enterprise ethical policies. And 3. Human AI collaboration is A, defining autonomy and overrides.
Domain 7. Third-party compliance evaluations. Question 1. Under the EU AI Act, what is explicitly required before a high-risk system can be deployed? A. Third-party conformity assessment. B. Public vote. C. OECD waiver. D. Open source release.
High risk requires A, third-party conformity assessment.
Question 2. The C2KA standard verifies what aspect of an AI system? A. Encryption strength. B. Content provenance and authenticity. C. Server uptime. D. Network latency.
C2PA is B, content provenance.
Question 3. Why is inspecting training data provenance as critical as code? A. Dictates storage size. B. Poison data fundamentally alters probabilistic logic. C. Third parties on the data. D. Required by web firewalls.
It's B, poison data alters the logic itself.
PBQ for Domain 7. Put these evaluation steps in chronological order. A. Submit AI BOE and provenance logs. B. Auditor performs adversarial testing. C. Auditor issues conformity certificate.
They are actually already in order. A, submit logs, and B, adversarial testing, then C, issue the certificate.
You got it. Domain 8. Data sovereignty. Question 1. Under GDPR, what must an AI system do if a user withdraws consent? A. Anonymize the data. B. Delete the data and potentially retrain the model. C. Quarantine for 30 days. D. Transfer outside the EU.
Oh, the painful one. B, delete the data and potentially retrain.
Question 2. How does data minimization impact AI training? A. Requires largest datasets. B. Process only strictly necessary personal data. C. Compress data files. D. Prevents edge device deployment.
It's B, only use strictly necessary data.
Question 3. If a U.S. model is deployed in Europe, which framework governs its handling of European data? A. IPAA. B. NIST. C. GDPR. D. ISO 27001.
Operating in Europe means C, GDPR.
PBQ for Domain 8. Which action violates EU GDPR regulations? 1. Processing EU data in Frankfurt. 2. Using data collected for security to train a marketing AI without asking. 3. Allowing users to opt out.
Action 2 is the violation. It breaks the purpose limitation principle.
Last one, Domain 9. Preparing for the exam. Question 1. Regarding model evaluation, which is true? A. High accuracy on clean data is sufficient. B. Evaluation must include adversarial testing and bias audits regardless of clean data accuracy. C. High-risk systems don't need testing if open source. D. Human validation is only for legacy IT.
It is B. You absolutely must do adversarial testing.
Question 2. If an AI generates unexpected outputs due to subtle manipulations in input data, what threat is this? A. Model theft. B. Evasion attack or prompt injection. C. Supply chain compromise. D. Denial of service.
Input manipulation is B. Evasion attack.
Question 3. What best differentiates shadow IT from shadow AI? A. Shadow AI exposes corporate data to external algorithms via unsanctioned models. B. Shadow AI operates on the dark web. C. IT is hardware, AI is databases. D. No difference.
It's A. Shadow AI leaks data into external training sets.
Final PBQ. Implement defense in depth for an ML pipeline. Max the control to the stage. Stages are 1. Data gathering. 2. Model deployment. 3. Continuous monitoring. Controls are input validation and prompt filtering. B. Scanning public datasets for poisoning. C. Tracking model drift in real time.
Okay, 1, data gathering is B, scanning for poisoning. 2, deployment is A, input validation. And 3, continuous monitoring is C, tracking drift.
And that is a perfect score. You are officially ready for the SecAI Plus exam. Keep studying, keep asking the hard questions about who or what is actually in control, and we will see you on the next deep dive.